In this session, we learned about ANSYS substep and convergence settings. Now, we are going to see ANSYS settings related to the Newton Raphson iterative method. In the last session, we saw that the Newton Raphson method calculates the stiffness of the deformed structure during every iteration. If a large number of iterations are required for the solution, calculating the stiffness of the structure every iteration is computationally expensive. Therefore, variants of the Newton Raphson method are used to get a more efficient solution. The graphical representation of these variants is shown below. Consider a load deformation curve of a weakly nonlinear structure plotted on the load versus deformation axis. Let F applied be the load applied on the structure. In the modified Newton Raphson method, stiffness K1 is calculated at the beginning of the solution. This stiffness is used to calculate the deformation in the structure, delta, and the reaction forces in the first iteration. However, in the subsequent iterations, the stiffness is kept constant, and deformations are incremented to account for the non-zero force residuals. As you can see, within a few iterations, deformations close to the actual deformations in the structure are reached. This is computationally less expensive compared to the full Newton Raphson method, where stiffness of the structure is calculated during every iteration. In the last slide, we saw how the variants of the Newton Raphson method, like modified and the full method, can be effective for the weakly and highly nonlinear problems respectively. Now we are going to see how to set the appropriate Newton Raphson method. Appropriate Newton Raphson option can be chosen by going to the Details window of the Analysis settings. In the Details window of the Analysis settings, if we click on the Nonlinear Controls tab, a number of options appear. The topmost is the Newton Raphson option. By default, it is set to Program Controlled. That means, software chooses the most appropriate Newton Raphson option based on the complexity of the FE model. It can be set to Modified, Full, or Unsymmetric. More information about the Newton Raphson options is given in the table. Stiffness of the structure is updated in each iteration in a full and the unsymmetric method. In the modified method, the stiffness is updated after a certain number of iterations. Full method is suitable for highly nonlinear problems, while the modified method is suitable for weakly nonlinear problems. In certain cases, like acoustic or high-friction problems, the stiffness matrix is unsymmetric. In such cases, the unsymmetric method is applicable. Full method provides faster convergence, but is computationally expensive. Modified method requires less system resources, but convergence is generally slow. Unsymmetric method is also computationally expensive, but is required for certain nonlinear problems.